My name is Thomas Watson. I hang out on GitHub a lot and do a lot of open source and mainly Node. I've written a lot of Node modules. I just tweeted a couple of minutes ago a link to these slides. So if you see some code in there that you want to look in details, look into in details, you don't have to like scribble and take all the notes now. You can just look on Twitter later. So I suggest, of course, that you follow me there and on GitHub. So with that out of the way, I work for this company called Opbeat. And contrary to popular belief, we are not a coffee company, though we love coffee, as one might expect. So instead of coffee, what we do is we do instrumentation of your Node app in production. So you can see exactly why some requests are slow and why some are fast and fix it. So, but that's not what I'm going to talk about now. What I'm going to talk about now is instrumenting Node and tracing Node in production. So how do we get good insights into a Node application while still it being a Node application, because Node applications are freaking hard to instrument. So what I mean by this, so normally you have, in this example, we have an HTTP application that receives an HTTP request. And at some point, it sends a response back to the client. And in the meantime, it might just query Redis to see if it has what it needs in the cache. It doesn't have that, so it's going to look in the database instead. And then it might write something to the database. And it would be really cool if we could figure out how long these things took. We call them traces. We want to trace how long each of these I/O requests take. And then we want to be able to group it all under a transaction, so that we can later refer to the request that actually caused these traces to occur in our production code. So, and another reason why you might want to trace your application, besides figuring out why it's slow, is if this happens. There's an error, and if there's an uncaught exception, what Node will do is it will just exit. And then you get a stack trace. That's cool, but you get a stack trace back to the latest async operation. So you can't see what request was active at this time. You can't see why you call this database query. There might be multiple entries into the database. So it would be nice to tie all these things neatly together, and that's another reason why we want to do tracing in Node. So I'm part of the Node.js Diagnostics Working Group, and one of the things that we work on is tracing. And to figure out how to solve this problem in Node, we have to dive into this thing called the event loop and learn why this is a problem. The event loop actually looks like this. So Node is, as you know, single-threaded. So only one piece of code can run at the same time. But Node is clever about what goes on in your application. So if you're talking to the database, the file system, doing an external HTTP call, it'll wait and leave blank space on the process for other stuff to appear. So here we have one request coming in, and it'll get into the router first and figure out which controller to call. And then it might do a database call, then there's nothing going on, and then a little bit later, the database calls returns, and you know the drill. And this is all synchronous code. So only one piece of these blocks can run at the same time. But then another request comes in, and it kind of interweaves itself inside the process. And so what you have is multiple requests going on at the same time. So that's why you might be tempted to do something like this, have a global with the current request and then refer to that. But obviously that will not work, because here we set it when the first request comes in, so that's request 1. Then another request comes in. We set it again to the request 2. And then, OK, this is cool because it's still the same request. And oh, no, now it's actually running the code from the previous request, but it's still pointing to the new request. So you'll get weird things happening. So that's not good. What we want to do is we want to have this happening in some magic way. We want to have current requests to point to the correct request based on the code that's currently executing in this thread. So there is a way to fix this. Does anybody know what this is? This is a monkey patch. And what do I mean by monkey patching? So this looks really, really dirty. Let's just imagine for a second that everything in Node, all async stuff is happening via set timeout. We all know set timeout. There's, of course, a lot of other places where async stuff can happen, but just look at it from set timeout's perspective. So first, when the application starts, we just save a reference to the actual set timeout function. And then we basically just override it with our own function. And then whenever somebody calls set timeout with a callback that they want to be called at in 2 seconds or whatever, we just make a note, which was the active request right now, and just store this in a closure so we can get access to it later. And then we call the original set timeout because obviously we want to keep the functionality. And instead of giving it the callback that the user provides, we give it our own callback. And the reason why we want to give it our own callback is because we want to, of course, be notified when the 2 seconds or whatever have passed. And then when that callback is called, we make sure to call the actual callback. So we don't want to break the user's code, obviously. But before we call the actual callback, we want to restore the state as it were when this callback was actually queued. So when the user called set timeout in the first place. So current request might have changed in the meantime. We want to just hold a reference to whatever it was in the meantime. Then we want to restore it to whatever it was before. Then we want to actually call the callback, and then we want to restore it back to the one when the callback was called. So that's another word for this is magic. Yeah, I wanted to get that GIF in there somewhere. This felt like the appropriate time. So basically, what we have to do, we have to patch the world. We have to patch everything for this to work, and it seems really, really nasty, and it kind of is. But if you run any monitoring solution in your production code, be it New Relic or my company Opbeat, this is actually what's going on. It's a little bit more clever than what you saw, a very simplified example. A lot of more guards, make sure that we don't break anything, but basically that's what's going on. So what we want to do, we want to patch every async operation in core of Node. So that's like timers, the next tick call on process. We've got promises now, the native ones, and we have libuv, which is basically libuv is where all the stuff that has to do with I/O, system calls, all that stuff. It's in libuv, which is a C++ module that ships with Node. And then we also want to patch certain third-party modules. Excuse me. You want to patch certain third-party modules that have their own callback queues and stuff. Like if you're using Bluebird, for example, every time you give a callback to Bluebird, it stores it in its own little queue and it doesn't touch the core. And when the promise resolves, we want to make sure that whatever it was before is restored. So we have the current context all over the place. So this is a pain in the butt, basically, obviously. So luckily, in the diagnostics working group, Trevor Norris have been working on this thing called AsyncWrap. And there's a link there to the diagnostic working group repo. We can see all the stuff we're working on. So I was making these slides, and then this thing happened. So he decided, this is Trevor Norris, he decided to rename AsyncWrap to AsyncHooks, which is a way better name, but he didn't consult me first. So have to fix this quickly. Good. So now it's called AsyncHooks. And it's been actually shipping with Node for quite a while. You just didn't know this. And normally when you want to require some part of core, you say require and then like HTTP or FS or whatever. But that part is not shipping yet. So the only thing that's shipping is the actual C stuff beneath the scenes. So you need to make a binding to some core stuff inside Node in the C++ library. And the way you do this is you call process.binding and then AsyncWrap. And this will, of course, be AsyncHooks at some point. But right now, and the reason why I show you this code here is because right now, if you are in Node 4 or above, this code will actually run. This will work. This actually ships, and it's been shipping for a while. The API have changed a little bit, but it's not in master yet. It's a pull request currently. So even if you build from master, this will actually still be the code that needs to run. So we get a binding to AsyncWrap, Then we set up the hooks. And these are the hooks that will be called every time Node does anything to do with asynchronous stuff, timers, HTTP calls, all that stuff. Then we need to enable the hooks. And then we need to define the hooks, of course. So there's 4 hooks: init, before, after, and destroy. And init is called the moment that you actually try to create the callback. So that would be like when you call set timeout. The init hook is called. And it gives you a lot of variables that I'll go briefly over in a second. Then just before the callback is called, in a synchronous context, so when the callback to set timer is called after, let's say, 2 seconds, the pre or before hook will be called. And then when it ends like in a synchronous way, then the actual callback will be called. And then just after the callback has finished running, the post hook or the after hook is called. And then at some point later, the destroy hook is called. It depends a little bit on what type of thing we're looking at. If it's a timer, is one thing. If it's a HTTP request, it's called sometimes when the garbage collection is being run. But it's a nice place if you want to do some cleanup to do it in there. So let's try to use this. Let's require fs, and let's try to read a file. And then I'm locking some stuff here. So I'm locking like just before I open the file, I get a file descriptor. Just before that, I write a user before, and then just after I've set it up, I write user after, and then when I actually get the file descriptor, I write done. So how does this actually look? Here we have the whole code. So first you'll see user before. That's like this line here, like just before SF open. And then here we are queuing a callback. So you'll see the init hook being called. And then right after the init hook is called, now we're down here. We haven't really done anything with the file yet or tried to read it. We're running synchronously down through the JavaScript. And then at some point, the file system responds back, say, oh, I have a file descriptor here. The pre-hook is called just before the function, the callback here is called. Then the callback is called, we see done. Then the post, and then at some point, you'll see the destroy. So how come we don't use console log? I use this magic log thing. So it turns out beneath, under the covers, console log is actually doing asynchronous stuff. It might do it in a blocking way on most platforms so that you actually get things out as you expect them, but it's actually using process.standardout.write to write to standardout. So if you try to use console log to debug what you're trying to figure out, how does this magic thing work, you write console log to debug something, then it was trying to do something asynchronously, so it call itself, and you will get like an infinite loop, and you'll get this error. So of course, we don't want to do that. We want to, how do we debug this when we try to develop this? We can either do a synchronous write to the magic file descriptor called 1, which is standard out. There's another called 2, which is standard error. But then we need to do our own formatting. It would be nice if we could have the richness of console log. So there's this magic thing called _raw debug that is basically console log, but it's synchronous. So we use that, and then everything works again. So this init hook, what does that give you, and what can you do, use it for? So you get a UID. So every callback that is queued gets its own ID. And you get that ID in all the 4 hooks. So you can keep track of which call is calling the before and after and destroy hook by using this UID as your key. You get a provider. Provider is, so right now it's a number. In the final one that's going to ship in Node, which will be backported to Node 4, by the way, it will be a string. But right now it's a number, and you can see what the numbers mean by in the REPL. You can just get the binding, and you can see say .providers, and you get like all these different providers. So you can see if it's like there's one called, where is it? Timer wrap there, number 17, timer wrap. So timer wrap would be if somebody tries to run set timeout or set interval or set immediate, it would be a timer wrap. So if you want to handle stuff differently depending on what type of async thing is going on, you can use this. And Then you have the parent UID. So in certain cases, one callback is queued based on another async operation. So you might have a parent, otherwise it will be null. And then you also have this handle. Both this will be the current handle and parent handle will be parent handle, obviously. So what are handles? Handles are just a way for Node core, which is written in JavaScript, to talk to libuv and V8, which are both written in C and C++. So it needs some way to transport data between the JavaScript world and the C world. And it uses handles for this. So if you take, for example, a look in NetConnect, this is inside NetConnect. So you can see inside, behind the scenes, when you do something with NetConnect, it actually uses the process.binding TCP wrap to get TCP, the TCP code from libuv. It gets then two handles, and then it instantiates the handles, and it puts properties on these handles. So these are the handle objects. And that is basically your this property inside inside each of the 4 hooks. So you can get access to like the port or the address of the TCP connection if you want to use that for some debugging or something. And then at some point later it will call the destroy in the socket, and that's when actually the destroy hook is called. Timers is a little bit funny. So basically, if you have 2 timers with the same number of seconds, they will share the same callback. So you will only get one call to init, one call to pre, and one call to post, and one call to destroy, which is a little bit weird if you don't know this in advance. So if you want to be notified of each of them individually, you have to still do a little bit of monkey patching. So how can you actually use this? So I wrote a little bit of code that actually show how you can get access to the current request at any point in your application using this new API. Bear in mind that some things are not covered by the API yet, so you will still have to monkey patch those things manually, like process next tick. When this ships for real in Node, process next tick will be covered, but right now it isn't. So there are certain things that you need to patch manually. Also the timers thing, as we talked about. So basically, you get the binding. We want to handle timers separately, so we just keep a reference to what's the ID of the timer provider. We set up the different hooks. We enable them, and that's it. And how does the hooks? Oh yeah. So we have an init state and a previous state. That's basically just a nice little map where we keep track of what was the state of the current request at the point of init and the point of the before or pre-hook being called. And then we have the init provider, and we just check, the init hook, and then we check if the provider is a timer, and we just abort because we do our own monkey patching of that, so we don't want to do anything with that. Otherwise, we just set, using the UID, whatever current request is in this map. And then we just restore it in the before hook. And in the after hook, we unrestore it, basically. And then we clean up after ourselves. And that's basically it. Some gotchas. So the handle creation time is not always obvious. So for example, you do http.createServer. You would think that that's the time where you actually give the callback to create server. And that's the time where the init hook is called. No, it's actually when you call the .listen function on the server. So sometimes it's a little bit tricky to know when the creation time of the handle is, and that's also when the init hook is called. Console log, as I said, is a little bit tricky. Right now, next tick is not covered by this, but it will be. That's why it's in brackets. Timers have the problem I talked about with sharing the hooks. Promises are currently not covered by this because V8 doesn't give us an API to monitor these things and promises. It's something that we work together with Google to fix. So hopefully it will be fixed soon. And if you have in your code base multiple people trying to use async hooks at the same time, only the latest, as of now, this might hopefully also change, only the latest one to register hooks will win, but that will hopefully also change. Then there's this bastard. So if people like use Redis, for example, Redis keeps its own queue. It keeps pool of TCP sockets open to the Redis database, and we'll like figure out when a response comes back, like which callback actually needs to be called based on the response from the Redis database, and that of course will like it would be totally we will not know like which request was responsible for queuing this callback. So you have to patch stuff like Redis yourself. Again, this is something that is actually being worked on. So there's a new providers API being made so that people who make modules like this, for example, Redis, can tell Node when these things happen so Node knows to fire these hooks. So that will also ship. But until all the module owners use it, we still have a problem there. Then there's ES modules. I love those, or something. So ES modules is what is the word? It's I'm blanking on that word. Yeah, you can't overwrite the stuff that the import statement returns. It's immutable. That's the word. Which means you can monkey patch it easily, or you can't monkey patch certain things at all in Node. So that's going to be a problem, but I don't know. We'll see. Finally, this is the link to the the final draft of the API for AsyncHooks. Is currently in a pull request. If you want to know more about how it's going to be when it ships, this is the place to look. The tracing work group, or today it's called the diagnostics working group. It was previously called the tracing work group. That's where you can get a lot of information about all the stuff that we work on. There's also more documentation for AsyncWrap or AsyncHooks. There's even an issue where you can keep track of like the progress of how close you are to shipping this. And with that, I'm done. Hopefully 1 minute over time. Danke je. Is that how you say it?